Hey, ROS developers, welcome back again to a new class, a new ROS developers live class. Today, we are finishing the live classes that we have dedicated to the Duckietown project. And I'm happy that today, finally, we'll be able to start training our robot by using a deep Q learning neural network. And that's great. So finally, after 3 classes, so we are about to achieve that. So I think that we better go straight into the point, and because we have some work to do. And then for the new people that is attending this live class, let me tell you how does it work. So I'm going to share with you right now the ROS project that contains all the material that we are going to use today on the class. That includes the Duckietown simulation, a notebook with full instructions, and some extra code that we have developed on the previous classes. So I'm going to share this with you very, very easy by using the ROS Development Studio. Okay, so you need to have an account at the ROS Development Studio. I presume that you already had, because it was on the notes of the live class that was indicating that. And then, so if you have that, then just let me share the notebook with you. So for that, let me show you my screen. So how I am doing this, and then you will see that it's quite easy to share projects, ROSjects, we call it. These are ROS projects containing a lot of material, and that you can share with anybody just by using a link. And then everybody can open and reproduce the exact same things as you are doing. And that's what we are going to do here today. So here is the notebook that we have today for this live class, and I'm going to share it by pressing on this button and copying this link. Okay, so this is the link that we should share. So I'm going to paste this link here on the chat. And the thing is that this link is too long for the chat, for the YouTube chat. So I need to shorten it. And for that, I'm going to use a tool of Google. Sorry, it's with 2 O's, Google. Yeah, that's it. So I'm going to paste the project link, and shorten it. This is not required in normal ROSjet. It's just for the case of today here of sharing this in the chat, because otherwise the chat is going to cut it. So here it goes, people on the chat. You have that link. Then if you press on that link, you will get the project. This ROSjet here, you will get that in your account at the ROS Development Studio. So you only have to click on that link. You will be redirected to the ROS Development Studio, put your username and password, and then you will get the whole project copied for you. Let me know on the chat, okay, see if you have any problem by getting the ROSjet, okay? So it's usually is working in all the live classes that we are doing. So I presume that there is no problem. I will wait a few seconds more so everybody has the project copied, because we are going to work on that project. Okay, so I suppose that everybody got it and has no problem. And then what we are going to do is to open the ROSjet. So in order to open that ROSjet, just press here, open ROSjet. And then you press open ROSjet, and that's it. Then you are going to get some stuff here, opening the computer on the cloud for you. It's a complete development system for ROS. So it's like if you have your own computer with ROS installed, but you don't have to. And also you can use Windows or Macs or any type of computer to develop with ROS. So you are not attached only to Linux machines, to Ubuntu machines, okay? So with this ROS Development Studio, so we are moving faster. Then here you have a README that says, okay, welcome, and then it's so simple, launch the Jupyter Notebook for further instructions. And that's on Tools, Jupyter Notebook. Okay, so let's go. So here is Tools, and let's select the Jupyter Notebook. And here we have, and select this live class 32 by clicking on it. And then here we have the notebook for the class of today. Okay, so let's follow this notebook and we'll go proceeding step by step. We are going to build on what we have done previously, okay? But you don't have to open your previous project that we did on the previous live class, because in this live class, we have included already the code that we developed on the previous class. So don't worry about it. So only concentrate today on the part that you have to learn today. We are going to see in a few seconds. So there is no comments on the chat, so I presume that everybody is following without problem. Let's go then. The first thing is that this is the episode 3 and the live class number 32. We have to do a disclaimer because we have to state that we have no relation with the Duckietown project. We have developed our own simulation and our own code. And we thought that this project, Duckietown, is a cool project that we can use it to show how to program with ROS and do image processing, do deep learning. And that's why we have selected. But we are not related with the project, okay? So don't take this as the official information or whatever. Okay, then there is Christian Pachal on the chat that says that he cannot log in because there is no option for Google or Facebook login. Yeah, that's right. You have to create an account. Sorry, still not possible. Sorry for that. And then let's continue. So what is in this class? So in this class, we are going to use finally the whole OpenAI ROS package to train the robots and to make them follow the line. And so this class provided as a project, that's what you have. And here you have a link for the video of this class that you will be able to watch after this class has finished. Then let's go to the content of the ROS jet. Well, it contains the notebook, the Duckietown simulation, fake navigation, and some other code from previous live classes, as well as the OpenAI ROS package. If you don't see this image here, this YouTube video, you have to select this cell that contains this and then press play. So then it will render for you that, okay? So whenever you see this YouTube, you have to do that. Then you select and then you press. Here you have a link to the previous class because we build on things that we have done on the previous class. So you can check it here, what we built on the previous one. And well, here it says what we built actually. So we built the structure of the task environment. We built a basic image detection algorithm. And then, well, actually we didn't do this Q-learning training algorithm. So that's the old version. So forget about that. We just stop it here because it was too much for that. And today in this class, what we are going to do is this. So we will put the robot moving there on the simulation, and then training and getting the reward increase. We are going to use the detection algorithm for lines only to check if the robot is inside the limits of that we want. Okay, so for that, what we are going to do is to train a neural network actually with deep reinforcement learning. And we are going to make use of the OpenAI ROS package for that, as well as some work of TensorFlow. The TensorFlow will be used to implement the actual neural network that will learn the deep reinforcement learning policy. That's the neural network that will encode the Q-learning policy that the robot is going to learn by using the OpenAI ROS framework. Okay, so let me state what I already explained on the previous class. That's the different parts that we have to learn to create in order to make the robot learn. First, we have the simulation. This is the simulation that we already have. is the simulation of the Duckietown. And actually, we can launch it right now. Let's do it. Let's launch the simulation. We go here to Simulations, and then select the launch file, because we are going to select a file that, a simulation that it's included into this ROS project. Inside this ROS project, we have included the Duckietown simulation. So for that, we have to go to our simulations workspace here. Then go to Simulations, then select Launch File. And here, from the menu that appears, select the main launch. Okay, and then press Launch. Then the simulation is going to appear in a few seconds. So let me leave it there. Okay, so what's the structure of what we have to do? Here we have the simulation. That is the one that is simulating the robot, the actual robot, as if we had this in real life. Then we have this connector, gazebo environment connector, that is the one that allow the algorithms, the learning algorithms, to connect to this simulation and then perform some tasks like pausing the simulation, resetting the controllers, setting initial positions, etc. So things that are very, very deep in the simulator and that apply for any simulation. This gazebo environment class, it's provided already by the OpenAI ROS package. You can go to this link here that we have provided, and you will see a lot more information and details about this structure. Okay, so I'm not going to explain this today, but you can have a look there. So you have here the link for the information. So this one is already done, so we don't have to do it, but we have to use it. Then we have the robot environment. The robot environment class is the one that connects to one specific robot in a simulation. So this is for any simulation, but this is very specific for the robot that you are using, that you want to train. Okay, so that's what we are going to do today, the robot environment. So we are going to create this class that allows the learning algorithms to access the sensors and actuators of the actual robot that we are using, that is the Duckiebot. That should be around here. So if we come here to the simulation, let me see, it should be around here, the Duckiebot. Yes, here it is. Let me know if you get stuck in some of the steps, okay? So I can help you and keep you following the lesson. Great. So we had to create today this robot environment. That is the class that provides access to the sensors and actuators to the learning algorithms. That's what we are going to do today. On the previous class, we created the task environment. Let me remind you what is the task environment. The task environment is the class inside this learning structure, is the class that specifies the task that has to be learned. And how does this? By computing the reward and also selecting the action and translating this action, transferring this action to the robot environment, so the action can be actually executed by the robot. And also it gets the observations from the robot environment and provides this to the learning algorithm. So the learning algorithm will be able to learn from what happens when an action has been selected. Basically, that's the typical reinforcement learning loop that you already know. Okay, so the learning algorithm selects an action. This action is translated from the task environment into the robot environment and actuated into the robot. And then it comes back an observation that the task environment is getting, computing the reward, and then providing everything to the learning algorithm. So the learning algorithm can do its job of learning based on the reward, the observation, and the action taken. Great. So today we are going to create the robot environment, and then we have to create this training script. That's the one that contains the learning algorithm and the reinforcement learning loop. So those are the two things that are missing, and we are going to create today. Let me see, what do we have here? Okay, so we start first by creating the robot environment. Okay, so we are going to attack this. And for that, we are going to create a file that is called the Duckietown environment. And let's go and open the IDE so we can create the files there. So go to Tools and then open the IDE. Great. So probably you don't have that open because I was working. So that's why I have all the three open. So here we have the structure of different workspaces. And for building these classes, we have to go to the Catkin workspace. Why? Because the code that we are going to execute is related to code that should be executed on the robot. And any code that will be executed on the robot should go to the Catkin workspace. Otherwise, if it's related to the creation of the simulation, should go to the simulation workspace. Okay. So on the simulation workspace, you can see that I have included here the Duckietown simulation. So those are the packages that allow us to launch this simulation. And they are included here. Let me remind you that you don't have, if you need to do, you want to do, for example, other training for other robots, you don't have to, you are not obliged to create a simulation and put it there. You can use some of the simulations that we already provide here on the simulations workspace. You see, we have different robots. And yeah, you can, for example, you can launch a VBA just by pressing here. So I'm going to do it just to show you, okay? And yeah, the system takes care of everything. Then it's going to, it has killed the previous Duckietown, and then it loads the VB8. And for that case, you don't have to have the simulation here. If it is a simulation that is provided by us, we have several here. So if you have that, you want to use any of the robots that we have here, then you can just use those simulations. Yeah, here we have the BB8 robot. And yeah, it controls by velocity, different cameras. Quite interesting. Give it, have it a look afterwards. Okay, let me relaunch again the Duckietown. So I'm going to relaunch again. So I will be up at the same location as you. Okay, let's go and create this Duckietown environment that is a robot environment class. So for that, we go to the Catkin workspace and we are going to put it into the let me see, it was into the lane following. Okay, so here inside the lane following, we have some stuff from the previous class here. And here is where we are going to create our class. So if we go to the lane following scripts, then here we have the, wait and see. Wait, here there is a problem. Okay, yeah, so so I have created, so I have included, and I didn't delete it. Let me see because I think that I included the file that we had to create actually. Yeah, actually, yeah. So that's the file that we have to create. So, yeah. Well, anyway, so we got it. So let's do it and let's just let's use it. So here we have already created this file. So it was supposed for the class that you should create it because we have here all the code that you have to put. But then since it is already created, so let's just open it. It's a Duckietown environment, so just open it, and then we got it. So we are going to use it. And now, let me see, because I think that maybe we'll have an error later. But okay, let's not move forward before. So anyway, so we have here the Duckietown environment class. That this is the class, and let me increase this the font size so you can see better. So this is the class that codes the specificities for accessing the robot. That is the Duckiebot. That's the one that accesses the sensors and the actuators as a ROS robot. So this type of class is structured in a way that can access ROS-based robots. So let's go to the different functions that this class has to implement. Okay, so here you have the structure that is empty for any other robot that you will need to do. So you can take this structure and just fill it the different classes. And in this case, that one here can be used as a template for another wheel robot that you have. Okay, so then which ones are the main functions that we need to get into done into this class? Well, the first one is the move base. The move base is the function that is called by the task environment. So this move base, it's a task that receives a linear speed, an angular speed, and then it creates the twist that will be sent to the actual robot. So how does it work? Well, the learning algorithm selects an action that, if you remember from the previous class, it was going forward, turning right, or turning left. Then that's the learning algorithm. So, well, actually, let me explain you from the beginning. The learning algorithm will check how many actions available are. And then we know that there are 3. So this learning algorithm is going to select one of those. It's going to say, okay, let's do the action number 2, for example. Then this is going to be passed to the task environment. And then the task environment is the one who has the actual actions defined. And then it says, okay, if it is a 2, it means that we have to turn right. Okay, so then it will say, if we have to turn right, I don't know how to turn right into this robot, but I know that in order to turn right, I had to move forward with a velocity of, let's say, 0.5, and then have also a certain rotational speed of, let's say, 0.1 radians per second. So this one, the task environment, is the one that decides those 2 values and then passes to the robot environment. Actually, the task environment is calling the move base function with those 2 parameters. Okay, so that's where we are connecting this class with the robot environment that we are creating here. And that's this move base function that we have here, and that we should have here somewhere in the code. So let me check, where is it? It's around here. Okay, so that's it. So that's the one that receives a linear speed and angular speed. And then based on that, you see it creates a twist that it's filled with those 2 values, and then it's published into the common belt topic of the robot. So that's how this is connected to the simulation. Okay, so that's a move base. It's in order to produce the actions that the learning algorithm has selected. So you can see the whole picture when the learning algorithm selects an action, how finally it is executed on the actual robot. Okay, so you have seen that. Now we have to see now how it works on the other side to get data. So how do we get data? The sensors, the observation. Okay, for that we have this get camera RGB image raw function, and we have 2 of them, and I'm going to explain you why. Okay, that's just a stupid thing that we did in order to move faster. Okay, but usually you will have only one because we only have one camera. Okay, but for this example, in order to get it done on time, so we had to do some tricks, and we needed to include a second camera that doesn't exist in the simulation. So if you go to the simulation and you check the robot, you can see that doesn't exist the actual camera, the second camera. So there is only one single camera that is, oops, sorry, I pressed wrong here. Here. Okay, so that's the camera, this one here. Okay, so then that's get camera RGB image is the one that connects to the topic of the camera, gets an observation, and produces and provides it to the task environment. So the task environment can use it for learning afterwards. Previously processing can provide it to the learning algorithm. Okay, so and then the camera 2 is exactly the same. Those are functions that are implemented into the task environment, so we are not going to implement them into this robot environment. Let me see. Okay, so all those functions, yeah, so there is a description here, but this is not necessary. This is information already repeated from the previous live class. Okay, so here is about the particularity of the two cameras. Then what is happening here? So what happens is that in order to train the neural network, we are going to use images of 80 times 80. Okay, why? Because we assume that with this size, the robot will be good enough. That will be good enough for the robot to learn, to understand that it's following the line or not. Okay, so that's the main camera of the robot. So that's the one that we use for providing the observations to the reinforcement learning algorithm. But then we have a second camera that with bigger precision, so what's the word for that? Bigger resolution, yeah, that is published on another topic. And this one is the one that we are going to use for the detection algorithm. If you remember, on the previous live class, we created an OpenCV algorithm that was capturing images and then giving us a dot on the camera where there was the yellow line. So we can use this as an observation. But actually, in this training that we are going to do here, we are not going to use the OpenCV information to train the neural network. We are going to train the neural network with the images, the direct images from the camera. And the OpenCV information that detects where the line is going to be used to automatically detect when the robot is out of the bounds of following the line. So we can say to the reinforcement learning algorithm, hey, you are doing wrong, or hey, you are doing right, because we know that you are following. So it's a way of using this camera. We needed bigger precision for that, bigger resolution. And for that, that's why we have included the second camera with a different resolution. But actually, how it should be done properly is just to have one camera of this resolution and then provide this image to the OpenCV and also convert this into a lower resolution and provide that second conversion into the learning algorithm. But we didn't have time to implement all that, okay? So yeah, so that's what we have now. Okay, so here are the two functions that will return the information from the cameras. And here is the class that we already have that is included here. It's the Duckietown environment. So this is exactly this code that we have here. Okay, so it was supposed that we have to create it, but I forgot to delete the file. So we are not going to do it anymore. So actually it was just copy paste. So we haven't lost very much educational purposes or educational lines. Okay, then so we have here, so basically we already have this class that connects to the robot. Let me just go a little bit more on this class just to let you know other things that we have not discussed here on the notebook. One thing is that the robot is connecting to those topics, the odometry, the camera, so it's connecting there. And here is also calling to the parent class initialization, the robot gazebo environment. So this is the init of this class of the robot environment. And when an instance of this is created that inherits from the gazebo environment, then here we also call to the init function, to the constructor of the parent class. And then we have included some useful functions that's very good recipe for not having problems when training with robots and with ROS and with gazebo, is to, before we start anything, we check that all the sensors are ready, and we check that the publishers are also ready. And so those are some functions that you can check later. But this is very useful to do it, because otherwise you can think that you are running and you are stuck in some place where you are receiving data that is not actual data for the training, and you have lost a lot of work. So you can check those functions there that is included there. And yeah, so this is checking. Then we have the callbacks for the topics that basically we are storing inside the class, this data. And then we provide that data when somebody is calling the function. So get the odometry, or get the camera, or get the camera 2, or the move base that you already know. Okay, so so far we have talked about this class here in the diagram. Here, the robot environment. Okay, so we have from here up to there, we have the whole pipeline done. Now let's go to the training algorithm. That's the most interesting part, and that's the one that creates the actual neural network and starts the training. So for that, what do we have? We need to create a config file. That config file is the one that will contain the learning parameters here, and as well as the task environment parameters that we saw on the previous class. So today, let's create this new file and add those parameters there on the file. So let's go here to the IDE, go to config here, and create a new file that is called Duckbot _ deep learn _ params.yum. And if we open it, then we copy the content of here. Okay, so what do we have here? Well, apart from the typical Q-learning parameters that you already know, it's up to here. So this is a typical. So how do you want the Q-learning to work? So that's it. Those are the parameters: the alpha, the gamma, the epsilon decay, the epsilon mean, all that you already know about that. Then we have some special parameters for the training that we are doing, in this case for the neural network that we are using, because we are not using a Q-learning on a table, but on a neural network. And well, batch size is the maximum size of pairs of observation and action that the neural network is going to take in order to learn. So we are going to see in a few minutes, where this parameter is being used. Then here is the maximum number of episodes for training, so 1,000. We'll finish here. And here it's just a parameter that says if the mean reward that we are obtaining is bigger than this, and we have passed the minimum number of episodes, so at least we have trained for 100, and we have this average of reward, then we consider that the task is done. And finally, here we have some debugging parameters. One is to monitor, is to store some results of the OpenAI Gym training. While this is being done, the training is done, then the OpenAI Gym generates some files containing data of the training that afterwards can be plotted. So if you put a true, then it will generate those files. And also quiet is for showing some printed messages on the screen while the training is done. So you can see what is happening. Now it's false. Okay. Then, yeah. So here there are some references to previous work that we have done about OpenAI Gym, just in order to, if you want to learn more about how does it works, why do we need this config file, how does it works, and etc. So just have a look afterwards, okay, to those videos in case that you want to learn more. And remember to save the file, because otherwise it will not be taken into account. Save or Control S. Then finally, so let's create the learning script. That's the learning script. Okay, so let's go to the scripts here and create another file, new file that is going to be called like we have here. I'm going to copy paste because it's quite a long name. Okay, so I copied something strange. It's not that what I wanted. Okay, let me see. Copy the name and then change here. Okay. Yeah, the N1 try algorithm. And here is the code of the algorithm. So let's do one thing. Let's select here the whole code with Control A, for example, or you can just select drag and drop. Then Control C to copy and come here to the file that I have created, the new file, and press Control V to paste. And then Control S to save. Remember that. Okay, so that's the script that is going to instantiate the neural network and start training it by using deep reinforcement learning. And how does it work? Well, for that, let me tell you that we are going to use here Keras. Keras, it's a framework, let's say, for creating deep neural networks with TensorFlow. And it's like kind of a layer on top of TensorFlow that simplifies the use of TensorFlow. I don't know very much about Keras, so I cannot tell you very much how it works, because this algorithm, we haven't created this algorithm. We just took it from the internet and we just pasted there with very, very small modifications for this framework, for this training, very, very small. And by telling you that, what I am telling you, well, what I'm telling you is that that is the power of this structure of training. Well, I put it on the top, and every time that I want to show it is to, oh yeah, so I'm going to show it here. Yeah, it's better like this. So we can move directly to the bottom. And yeah, so in this structure, so I can, if I have the simulation that I have, because I have provided already, this class, it's already provided by the OpenAI. This class, maybe it's also provided because if you check this package, you will see that there are several robot environments for many robots that are already simulated. And then the only thing that I need to know to do probably is the task for the things that I want my robot to learn. So maybe I only have to create this, and then I will take this training script from somewhere else and just plug it here. Plug it here and do the small connections that needs in order to transfer the action and get the observations and reward. But as you will see, this is very similar in all the cases. So that's the powerful of this, that you can, if you don't like this algorithm that we are putting here, you can just remove that file and figure out which one is the algorithm that you like and plug it. And you will have the exact task environment, the exact robot environment, the exact gazebo environment, the exact simulation, but training with a complete different algorithm. So you can test if different algorithms work better or not for the same task and for the same robot. You know, this is super powerful. And you can get those algorithms around the internet. You don't have to develop yourself unless you are interested, of course. If you are interested, that's your point, that's very great. But if, for example, you are just interested on generating robots that are able to do things, then you can use the pieces that are there around the internet and just plug them here. Remember that we are providing all those robot environment, gazebo environment, and simulations. We are providing this inside the ROS Development Studio. So you can get those classes there. And maybe some of the task also environments. It depends, because task environment depends a lot on what you want the robot to do. So the only thing that remains to you is to grab some nice algorithms, or just grab them and try. That's what we have done here. Exactly. So we found those this N1 try algorithm that was implemented using Keras. I have put here a link to Keras, to the main documentation, and especially I have put another link here to the sequential model, that this is the type of network that it is implemented in this algorithm. So you can get the information here, how it works, and a lot more details, how it is trained, how the different types of optimizers and output functions, etc. So the activation functions, etc. So just have a look by yourself, okay? So now, just let me tell you that here in this class, so let me see. So here it is the main, okay? So that's the program that we are going to launch. And of course, we initialize the node of ROS to indicate that it's a program of ROS. Then we load the parameters. These are the parameters that you have seen here. Those parameters here, okay, because are related to the QLearn, and the QLearn is implemented in this training script. Remember here, the training script. Okay, so that is why we are reading that here. Sorry. Okay, and then we create a class, an instance of that class with all the parameters, and then we run it. Let's see what does it mean to create an instance of this class. Okay, so what it means is that so we are creating this, and in this class, the first thing that we do is to create an instance of the environment of the Duckietown for following lines. Okay, so this is one of the few things that we had to add to this code. Of course, because this code doesn't know what we want to do this code was a general code around there. So now we have to particularize for our task. Then we say, okay, please create an environment of our class. Then here, okay, so this is monitor for what I mentioned before, to generating data. And then here is accepting all the parameters. And finally, here is where it is creating the model, the sequential that I already mentioned here is the neural network. And then it generates the neural network with the different layers. On the input, we have the input dimensions that it's a parameter here. Let me see here, the input number of observations. And this number, it's all the inputs that this neural network is going to have. Basically, as I mentioned, it was images of 80 times 80. So we are putting all the pixels as an input to the neural network, and then the 3 colors that we have also. So times 3. Then if you multiply this, that means 19,200. So that's the input, and then a hidden layer of 200. Then we create another hidden layer of 4,800, and finally we create the output that it has the number of actions that is actually 3. that this is the one that provides the action based on the input, on the observation. And then we create a model. So that's it. So in self-model, we have the neural network that is going to be trained. Then that's on the init, okay? And then the next thing that we have is this run. This is the run. This is the function that will go on a loop for all the episodes that we have indicated. And inside every episode, it will do another loop for all the steps. And the steps, well, will finish when it's done, when it says done. And this done depends on getting out of the path, crashing, or whatever you have defined. We have defined there. Actually, it was number of times of steps, and also if it is it's out of the bounds. It's out of the bounds. Actually, if it is out of the bounds that we have defined for the angle that the OpenCV detector is providing us. So we are saying that this OpenCV says, okay, the line to follow is too far or too close, then you are out of the bounds, then you are done. Okay, so this is that's the typical reinforcement learning loop. We choose the action, and then the choose action is a function that is defined around here, choose action here. And you can have a look that it uses, let me put it bigger. So it uses either a random action based on the epsilon value. You know what this means in reinforcement learning already. Or it gets an action from the model that has been trained up to the point, as it has been trained up to the point. Okay, so that's the action, how it's chosen. And then this action is passed as a step into the task environment. That is this one here. This is the task environment. So we generate a step. As you have seen how the task environment takes this action and transforms into a command velocity. And based on that, then a reward is generated. And the next state, the observation, is also generated. Then we process this, and then we store into a list, into a queue. So this is a specific method for learning, for making this neural network to learn. That is, we are doing this loop and storing all the information in a queue. And once this loop of this episode has finished, then is when we replay all the information, and we make the neural network learn. So during this episode, the policy is actually not being updated. It's only been updated at the end of the episode, or at the end of every episode. That's a particularity of this learning algorithm. Okay, so if you see the previous implementations of other classes, you will see that we are updating here on the same loop all the time. But those are just the few modifications. Actually, there is no modification here because we are modifying nothing, because the whole loop is the same. So this environment is provided, the observations, the preprocessed state is also provided, that it's a way of reshaping the information into the proper format for providing this to the model that we are doing. And basically, that's it. So that's the learning loop. So we have that done. And then the only thing that remains is to generate the launch file that will allow us to launch it and start the training. So let's do it, and let's launch it, the training. So for that, let's go to launch, create a new file that we are going to call, let me see how it requires to be called. Whoops. It's, yeah, let me copy everything here. Start learning deep Q. So let me change here the name, open the file. It's empty, copying this, Control A, Control C, come on here, Control V, then Control S to save. So we got it. And then that's it. So that's it. Then the only thing that remains is that we launch this so we can start learning. And how do we launch this command? Well, for that, we need to open a shell. The shells, you can find the shells here in Tools and go to Shell. And then let's launch this command that will start this file, this ROS file. Sorry, not that. Yep. Control copy. Control B. So let's start the training. Okay, so it says can locate this node, ROS params. Okay, yeah, so that's probably because we don't have permissions for execution for this. So we have to go to that package, ROS-cd lane following. And there inside the scripts, then let me see. Yeah, so chmod plus X of the Duckbot and one try algorithm. Okay, so now I have changed the permissions and then I'm going to launch it again. And there it goes. Then it's creating the model. And then if we go to the simulation, we'll see after a few seconds, it takes some time, okay, to generate that model. So don't despair. Don't despair. And it takes some time, but then you will see when it starts training. And in the meantime, I'm checking the chat. It says, the other guy says, thank you. Okay, the other guy, thank you to you. Then there is a name in I don't know if it's Russian, that says, hello, I'm your subscriber. I'm happy that you are a subscriber of us. Thank you very much. And then there is Manhuna that says, thanks, Robotic Night community. Thank you very much for attending, for being here. And yeah, so we have started here the training. And as you can see, some commands are being generated. The robot is moving in some direction. Now it's crossing. You see that it's doubting sometimes. So this is the random actions that the current model is getting. So now it has a stop for some reason. So that means that it was too out of the bounds. Then this episode was finished. And then the Duckiebot is set back to the beginning and start a new episode. And all the information has been used to train the model. Okay, so you can keep it running, then it will take some time, but at the end, the robot will learn to move forward. You can check how this is improving by opening here on the tools, the OpenAI reward chart. So you will see how the reward is being generated and it's been improving. Well, that's going very bad. Yeah, so that's the first one, is a reward. Yes. So yeah, so you can leave it there, training, and then at the end you will have something like this. Okay, let's hope, but let's see. Then from my side, that's all here. And please, if you like this, I know that it's a lot of information, very fast, but I think that you are going to get a lot of this. If you analyze the code and you go step by step, you are going to learn the practical things of using neural networks, reinforcement learning with simulations connected to robots that are based on ROS. So please have a deeper look at all the code. Show us where we have failed, where we have errors, and let us know better implementations, comments, questions, whatever. But please give us a like on the YouTube, because that's, if you like it, because that's what allows us to know that you are liking our work. Then just let me tell you that if you want to learn more, we have the Robot Ignite Academy, as has been mentioned here on the chat. It's an online academy where you will learn many different subjects about ROS, like ROS basics with C++ or Python, and autonomous cars. We have autonomous cars. We have advanced learning OpenAI courses. So have a look at that. I have included here a coupon, a discount of an 8% of the discount if you subscribe before tomorrow this time. And then also let me tell you that we are doing a podcast. So we are already episode 22 on the podcast, and we are interviewing super cool guys that are experts in ROS, and they are providing a lot of information about how they program their robots. Check those 2 episodes here. Some of the most listened. One for humanoid robots, another one for ROS 2, for example. And basically, that's all from my side. So my Duckiebots still learning there, still training. Let me know how yours is going. I can stay here for a couple of minutes more. Afterwards, I have to rush into some other work. And so I'm here waiting for your questions on the chat, if you have any. And I have here, so there is Pradeep that says, thank you, guys. Thank you very much, Pradeep. And let me know if that worked, if your Duckiebot is moving around and training using the images or not on the chat. Did you achieve that? So were you successful? You know, doing those live classes in real time, that's difficult to make everything work. But fortunately, we have a nice environment that is the ROS Development Studio that we can use it for doing this kind of classes. So I would suggest you that in case that you would like to do this kind of classes, live classes, you use it. You can use the ROS Development Studio also for doing this kind of live feeds, or not live, just record you can use it because it's free. You have a free account, so go ahead. Oh, here there is a question by Trickow that says, when I run the code, it says using TensorFlow backend, then it exits immediately. Okay, that makes no sense, Trickow. Let me check. So that message, then I suppose that you mentioned this. Let me show my question. Sorry, my screen. My screen here. So I presume that you mean this message here, using TensorFlow backend. Oops. Here, using TensorFlow backend. Yeah, you are mentioning that. That's correct. That means that it's doing something. But if it ends, then there is some problem in the code probably. But if you don't get any other message, that's very strange. That's very strange. Then Martin is asking, this is great. How long time will it take to train to get somewhat good results? Well, actually, we don't know because we didn't have the time. As I mentioned, we have for 100 episodes here only, and it was okay. It was okay, not bad, but it's not what you would expect. Also, this is just an idea. That's an example, but for you need to improve this model in order to, for example, to handle other situations, like, for example, here on the intersection when there is nothing. So what to do in that case? Because the training algorithm will say that there is no line and you get lost. So this is an example, and I ask you, also you have to allow the robot to write to this part, so it will learn how to turn when this happens, because here is very useful. Actually, what I would do here is to put the robot more to the front. So it receives some images from this, but then afterwards some images from that. So then it can learn to turn, and then turn again, and then turn again, and then turn again. So that's, you have to train your robot in all that, not only on moving forward. So I cannot answer your question. Then Trickow says, all processes on machine have died. Rosange will exit shutting now processing monitor. These are all the messages I got. Okay, then do one thing, Trickow. Just generate a video and send me the video. to my email, and then I will have a look at what happened. Okay, so we'll keep in contact through the email because I have to run and finish the class here today. So please, Tukao, send me an email with this video that shows what happens, and then we can keep a discussion through email and solve that problem. Because you got the same code as I got, then it should be a stupid mistake, a very simple thing that is something missing, very stupid thing. Don't worry. And then Martijn says about the how long, please, you try and you tell us. Okay, we have published recently another page that is called about the ROS jets. So as an example of ROS jet, what does it mean, how you can get it. And there we have a video of a car pole that is training to keep it there. And it's using, I think it's using also deep Q learning, but I don't remember exactly, but that took many hundreds of steps, of episodes in order to get the pole balancing. Yeah, actually there is a video that shows 2 hours of reinforcement learning for the car pole. You can look in our YouTube channel and then you will get this video. You will see that it took 2 hours for a car pole. That is a lot easier because it's just the space is very small and the observations here, it's a lot more complicated. So have a look. Okay, so I have to finish. I'm happy to see here on the chat also that Tricao has found the problem and it was a stupid mistake. Yeah, very good. I'm very happy, Tricao, that you found it and you are able now to start training. And guys, this is the last one of Duckietown related courses. If you want to have more, because there is a lot more things about this, like detecting the different signals, detecting the traffic lights, detecting other robots there. So if you're interested, please write us something. Tell us something on the comments and tell us if you would like that we keep this serious or if we will change to another subject for the next week. Okay. So thank you very much, guys. It's been a pleasure to be here with you and see you on the next week. Bye.